Okay, I'll make sure you can see the pictures. Okay. So it's just going to take us through some reminders of what forces are. You whack a hockey puck across the ice and into a net. You ride to the park and climb the monkey bars. Every day you use force to move things. Anytime you push or pull something, you use a force. Sometimes you can see the forces that cause an object to move. A pitcher uses force to throw a baseball. The batter smacks a home run with the swing of a bat. Other times you can't see the forces causing motion. And we're going to talk about that invisible motion force later. Do forces always cause motion? What do you guys think? I want you, by putting your hand up, if you think that forces always cause motion, raise your hand. We've got a few hands up here in school. Okay, if you don't think that forces always cause motion, raise your hand. We've got a lot of hands up for here. What do you think, Richie? You're going to put your hand up for that one? Okay, here we go. Forces don't always cause motion. Sometimes forces are in balance and objects stay still. If you sit still on your chair, you push down with the force, but are your chairs breaking right now, guys? No, because it pushes back up with an equal force. An object only moves when the force acting on it is greater than the object's force. So, for example, the Golden Gate Bridge is a really good example of this. Okay, the forces are balanced so that bridge does not break when things go around it. Sometimes your force is greater than the object's force because your mass is greater. Your mass is greater than a basketball's mass. Your body creates enough force to push yourself and the ball. In seconds, you can lift the ball, jump, and do a layup. Ellie, do you have a question? We saw that. Yeah, you guys remember that video we watched in Mystery Science? They kept putting the rubber bands around, and rubber bands around, and pretty soon it did what? Yeah, it exploded. It exploded. So why can't I throw a football into outer space? Anybody wonder that question? What's the answer? Who thinks they know? On the count of three, we're all going to yell. Are you ready? 1, 2, 3. Gravity! Yeah, gravity stops a football from going into outer space. Gravity is the pulling force between objects with mass. The force of gravity increases as mass increases or as the object gets closer. Every object in the universe attracts other objects with this pulling force. Objects with a great mass like Earth have a strong pulling force. On Earth, all objects are pulled toward the center of the planet. That's why the football falls to the ground. We're going to try a little experiment. You guys ready? I want everybody to stand up. Everybody stand up for me. Richie, you ready? You do this with us? Okay. We're going to do a little experiment with gravity here. I want you to hold your arms out to the side like this. Everybody hold your arms out. Okay? And I want you just to hold them there. Just hold them. Hold them. Hold them. Hold them. Is anybody's arms starting to feel a little heavy? Yeah. Have you guys suddenly gained weight in your arms? No. But so why are your arms starting to feel a little heavy? What's happening right now? I'd love to see a hand. I hear lots of chatting, but I don't see hands. Lydia? Gravity is doing what with your arms? Pushing them down. Very good. Put your arms down and have a seat. Voice is off. Voice is off. Gravity is not visible. Can anybody see gravity right now? Could you see that thing pushing on your arms? No, but it was there. So, how many of you have ever played pinball? Have played the pinball game? Raise your hand. We've got a few hands up. Richie's got his hand up. I like it. Okay, let's see how that works. So objects need forces to change direction and speed. A pinball machine uses many forces to change motion. It uses forces to speed up, slow down, stop, change the direction of the ball. To score points, players must keep the pinball out of the drain. Players use flippers to force the steel ball up the table. The ball moves straight until it hits a bumper. The bumper provides a force that changes the ball's direction. As the ball rolls up the table, the force of gravity causes the ball to lose speed. When the ball rolls back down the table, gravity's pull causes it to gain speed. So in one arcade game, there's a ton of different examples of gravity and of different forces. So this kind of goes back to what we did a couple days ago or before break. Will a marshmallow fall faster than a baseball card? Okay, I want you to raise your right hand if you think the marshmallow will fall faster. Raise your left hand if you think the baseball card will fall faster. I am seeing almost everybody with their right hands up. Let's see if you guys are right. So will a marshmallow fall faster than a baseball card? Yes, but not for the reason you might think. The marshmallow weighs more, but gravity causes all objects to fall at the same speed regardless of weight. Did you hear that? Gravity causes all objects to fall at the same speed regardless of weight. What changes how fast it falls is air resistance. Air resistance is a force that changes the speed of falling objects. Air pushes against both the marshmallow and the card as they fall. The card's shape makes the card catch more air. So the upward force of air is greater on the card. Without air resistance, the card would fall just as fast as the marshmallow. So, for example, do you guys remember the videos we watched of the man who skydived and did all of his jumps? Do you guys remember those videos? Well, how many of you have ever seen skydivers put their arms out like this? Okay. They're doing that, boys and girls, to increase how much air resistance is on their bodies, and that slows them down. If they didn't do that, they would have less air resistance, and they'd go a whole lot faster.
You don't have to sometimes if you do this, you down.
Oh, I don't see hands. And if we continue to talk in the class without raising our hands, we're going to lose some dojo points. Okay? So, boys and girls, how many of you have ever seen a bird flying in the sky? A few people? Yeah. So how do birds fly? Well, to fly, birds need a force greater than gravity's pull downward. Birds take off with the forces created by flapping wings. Some birds will run into the wind when taking off. The rush of air under the wings lifts them up. To stay in the air, birds still use force because gravity keeps pulling them down. Some birds keep flapping their wings. Others, like hawks, can ride air currents caused by warm air rising over cold air. As air rises under the hawk's wide wings, the bird soars upwards. So you can see a couple of different birds. So how many of you have ever seen a hummingbird? Anybody seen a hummingbird? Okay. Did you know how many times hummingbirds have to keep their wings flapping to stay in air? Because they almost look like they're just stopped in the air, right? As they're feeding. They have to beat their wings about 100 times every second. So like this. They just flap their wings 100 times. Pretty crazy, right? And we're going to keep talking about the rest of these a little bit, but boys and girls, there are so many cool things about forces that we're going to keep talking about as we keep learning about forces. Talon, do you have a question? Yeah.
When falcons when they dive down, it's like aerodynamic, so the air just goes right over them or below them.
Can for sure. Could you hear that, Richie? Okay. Okay. Any other questions about forces so far? Xander?
Skydivers do this sometimes. They go a lot faster.
Yeah, so if they put their arms down or behind them, yeah, they decrease the amount of air resistance, so they go a whole lot faster. Lydia?
Yeah, they push things down. I didn't know them when just float and nothing happened.
Well, think about this here. Is there something inside that balloon? Is helium gas maybe weigh more than the air? It does. Yeah, but that's a great question. So when you let the gas out of the balloon, what happens to it? It goes down. Very good questions. Well, Richie, that is the end of our whole group lesson. Now I would say you want to go ahead and get online and do your session 4 science assignment, okay? While the read aloud is still fresh in your mind. Sound good?
Mm-hmm.
Okay, so we'll just talk to you a little bit later, okay? Have a good rest of your morning.
You too.
Everybody tell Richie bye.
Bye. Wait,
All right.
today was Wednesday.